So let's look at the area model and also what we call the partial products model, which we like as educators because they help us to answer the why questions that students will have. So let's take a look back at this. So instead, I'm going to do the same exact problem, but I'm going to solve it using the area or the box method. So I'm going to try to draw a more or less a rectangular box here. It's a little wider. And if you've already read the chapter, you'll recall that the idea here, the reason we call it an area model is because we're going to give this box dimensions and we're going to solve it as if we were trying to find the area of the box. So up here we're going to say that this is a dimension of 57. And over on the left, you're going to say this is a dimension of 49. Where did I get those numbers? Well, from right over here in the traditional method, 49 and 57. Except I don't actually want to just simply write the number out as 57 and 49. I want to break it into pieces. So I'm going to erase that and rewrite. Instead of 57, I'm going to write 50 plus 7. And what we're implying here is that this portion of the line is 50 and this portion of the line is 7. 50 plus 7. And then we do the same thing with 49, except we say 40 plus 9. And again, we're implying that this length here is 40 and this length down here is 9. Let me just fix this so it doesn't look like a 6. Okay, now you want to go to each small rectangle and figure out what the area would be if the dimensions were whatever the dimensions are in this picture. So in the upper left hand corner we have a dimension of 40 by 50, which that would make the area 2,000. And that's pretty easy for me to figure out because I know 4 times 5 is 20 and then I have 2 zeros, so it's 20, 0, 0. So it's a simple calculation to make without having to sit and think about it too long. Okay, upper right hand corner, we have 40 by 7. That would be 280 as an area. Again, I'm just saying 7 times 4 is 28 with a 0, so 28, 0. That's my shortcut. Lower left hand corner, 9 by 50. That would be 450 if I was finding the area. And lastly, in the corner, bottom right, we have 9 by 7, which 9 times 7 is 63. Now to complete a partial products box or area method multiplication problem, which is what we have here, we want to take each rectangle and we want to add the quantities up. So I'm going to purposefully write it in this order. I'm going to write 2,000, 450, and then I'm going to write 280, and 63, and I want to add those values together. Before I do that, I want to point something out. Notice that 2,450, if I were to add those together, what I get is this number over here on the left in the traditional model, the bottom row of the add-ins we have here, 2,450. Where did that number come from? Well, actually, it came from these two small rectangles, the 2,000 and the 450, those areas, 40 times 50 and 9 times 50. That's where those numbers came from. They're the same number. If I look at 280 and 63, I see that those numbers will total to 343, which if we look at the traditional method over on the left, that number appears as well. So if I add these 4 numbers up from my area model, I'm going to get the same total that I had from the traditional method, 2,793. But contrary to the traditional method, which kind of is pretty abstract, not connected to anything tangible, in the area model, I can see where these numbers came from. They're area, they're numbers that actually represent the area of the rectangles in the large box. I didn't use any carrying of numbers or anything that seemed really abstract or something that we can't explain. Everything that I showed in this model, I can explain where I got the number and why I got the number. So that's the significance of the box method. Now, there is one problem with the box method, and that is it is not very conducive to being an engineer sitting and finding the calculation. Now, of course, if you're an engineer and you're finding calculations of large numbers, you're probably going to use a calculator, but small numbers, mathematicians do want to be able to scribble down a note and figure out what the value of two numbers that are being multiplied are. So it's hard to picture somebody sitting down and making a box. Even though it's valuable as a teaching tool, probably need to give students another step to make this multiplication strategy more meaningful or more useful.